math. Let's do it. So first thing, I just want to go over just quickly one of the homework problems, because the homework problems, a few of them were different than the example problems in the sense that there was like fractions. So I'm going to go over this one, number 10, and you guys can all follow along with me. So here we find, what type of triangle is this? Equilateral triangle. That means the sides are equal to one another. So I'm going to set them equal, solve for x, and then plug x back in to get the length of side AB. So I set them equal. I want to get rid of the fractions. So I'm going to multiply both sides by 10. 10 divided by 2 is 5. 5 times 3 is 15. That was a very fast way of doing it. Or you could do 10 times 3 is 30 over 2x plus 10 times 4 is 40 equals 10 times 1 is 10 over 5x plus 9 times 10 is 90. 30 divided by 2 is 15x plus 40. 10 divided by 5 is 2x plus 90. Now I solve for x, so I solve for x by subtracting 2x from both sides. I get 13x plus 40 equals 90. Subtract 40 from both sides. And I get, interestingly, 13x equals 50. I say interestingly because when I go ahead and divide both sides by 13, it's quite clear that there is no simplifying there. My answer is simply 50 over 13. So that's x. X is 50 over 13. Okay, so what do I do now? Well, I want to solve for side AB, so I just plug it in here for x. I can plug it into any of these, and I'm just going to go ahead and choose to plug it in here. So I get 1/5 times 50 over 13 plus 9. Now, I could do 50 times 1 over 5 times 13. I could do that, and I'm going to. But I could also notice that 50 divided by 5 is just 10, right? And so this just becomes 10 over 13. You see? That's the way that I would do it. But if that's too challenging for you guys to just do that all in one step, you can just go ahead and do the multiplication and then simplify. And what would the simplifying factor be? What goes into 50 and 65? 5, right? So it would be divide top and bottom by 5, you get 10 over 13 plus 9. It's the same deal. Does that make sense? Okay. Any questions on this so far? No. What do I have to do with this 9? I got to get it in terms of the same denominator fraction. So 9 times 10 is 90. 9 times 3 is 27. 90 plus 27 is 117. So this becomes 10 over 13 plus 117 over 13. And I get 127 over 13. That should be your answer unless I made a mistake. Any questions on that?
Are we going to have a problem like that on the quiz?
Potentially. Would I be inclined to give you like numbers like 50 over 13 and then like 117 over 13 in terms of fractions? I wouldn't be so inclined to do that because like, well, not that it's hard. I'm glad to give you hard problems. It's just arbitrarily challenging fractions. But you can definitely assume that I'm going to have answers where x is a fraction, probably more like 5 over 3 instead of 50 over 13, you know, and then you're going to be plugging that into solve. Does that make sense? Okay.
And then for the 10 over 13 plus 9, so you just multiply 13 both sides to get rid of the fraction?
So what I did, no. What I did is I multiplied 9 by 13 over 13 to get 9 in terms of a fraction. How do you convert a whole number to a fraction? you multiply it by the same thing on the numerator and the denominator. So it's a good question. So if like I want to turn 4 into some fraction over 7, like I want to do 4 plus 1/7. Well, I can't just combine it. I can't just say, oh, it's 4 plus 1 is 5 over 7. I have to turn 4 into a fraction. So I do 4 over 1 times 7 over 7, and that becomes 28 over 7. And now I can combine 1/7 and 28 over 7 because they have common denominators. Does that make sense?
Yes. Yeah. Can you just divide 10 into 13 and then get decimal and add that to 9?
Sure, but your answer won't be as accurate. Does that make sense?
Yeah.
Okay. All right. So that's that for that part. Now we're going to move forward into our new lesson, which is lesson 15.3. Any more questions on that last one? Yes, ma'am? Go ahead.
For number 15, can you
Just give you the general idea of that? Yeah, sure. I had a feeling there was something else. I had a feeling. Whoa, spooky. Okay. A plane is flying to the ground, parallel to the ground. Along AC. When the plane is at A, air traffic controller at tower T measures the angle as 40 degrees. After the plane has traveled 2.4 miles to B, he measures it at 80 degrees. How can you find BT? Okay. So when he's at A, this angle here is 40 degrees when he's at A. When he's at B, the angle here is 80 degrees. Oh, man. Oh, okay. How can you find this? Wow. All right. Well, when he's at A, because look, if I extend both of these lines out, here, then I can see that this angle and this angle are what kind of angle pair? Alternate interior, right? So if that's 40, then this is also 40 degrees, right? And then when he's at B, the angle is 80, which means that the angle between this line and this line is 40 degrees. Does that make sense? So it's an isosceles triangle, which means that if that's 2.4, then this is 2.4. How did I figure that out in that case? Because I knew that, what lesson are we on? Isosceles and equilateral triangle. It has to be something like an isosceles triangle. And so I was looking for the fact that, wait, those angles are equal. Does that make sense? So those are kind of context clues, things like that. Good question. All right, let's continue on. I'm going to seek to do my best in presenting this part of the lesson. 15.3, triangle inequalities. Now, let's say I've got this triangle here, and I do have this triangle here. Okay? God bless you. I have the blue side, the green side, and the red side. So I've got three sides of a triangle. What the triangle inequality theorem is saying to us, and we're going to get to that in a second, is something to do with the lengths of the sides of a triangle and how they relate to one another. So let's take a look at this. Let's say in my little animation thingy here, I've got the red side you see is 10. I've got the blue side which is 6, and I've got my green side here. Now the green side can change, okay? My question to you is, what do I know about, in terms of a relationship of the green side and the blue side and the red side? Well, let's take a look. If the blue side is 6 and the red side is 10, the shortest at the green side, look what's happening to the green side. You see it's getting longer, and now it's getting shorter, right? The shortest that it could be is 4, and technically, can it be 4? No. Why? Is that a triangle? No, that's a straight line. So the shortest it could be is 4, right? And what do you guys notice about the side lengths, the green and the blue side, as compared to the red side? They're equal, right? The green plus the blue is equal to the red, right? Okay, so that's one thing. But now let's go the opposite direction and keep making the green side longer and longer. And if you take a look at this, the green side's getting longer and longer until, bam, it's 16. And that's the longest it could be, but technically it can't even equal 16, right? Because that's just a straight line. It could be a little bit less than 16, like 15.9. That's still a triangle, but that's not. What do you notice about the red and the blue side as it compares to the green side? They add up. Does that make sense? So what am I noticing here about these triangles? Well, let's take a triangle that actually works. Let's say this triangle here. Oh, it'd be nice if I could just set it equal to something. Anyway, let's say this triangle right here. Let's just pretend that that's 9. I can't make it equal exactly to 9, but let's say that this is 9, right? I've got a side length here. This is 9, the blue side is 6, and this is 10. Okay? What do I notice about the green side plus the blue side? 9 plus 6 is what? 15, right? So it's bigger than 10, right? What do I notice about this? 10 plus 6 is 16, which is bigger than 9, right? And then 10 plus 9 is 19, which is bigger than 6, right? So if I add up any of the two sides, they're longer than the third side. Does that make sense? But if I get down to my shortest length here, 4, and now I add them up, well, hey, in this case, 4 plus 6 is equal to 10. Is it longer than 10? Is the sum more than 10? No. And once I get to this line, that's the point where the sum of my two sides are no longer bigger than my third side. Does that make sense to you? Okay. And if we take it a little step further, and I'm going to make it look like a triangle that does work. So here, like, let's say the length of my side here is 8, right? What if I made the length of this side like 2, right? Or even better, like what if I made this red side really, really, really long, like 20 or something like this? What you'd end up having is something that kind of looks like this. Like, I've got a triangle, and then another side, and then if this side is just really short, well, it can't even reach, you see? Does that make sense? You'd be left with one side kind of dangling off like that, right? So why? Well, because these two sides, the sum of these two sides isn't as long as this side. Does that make sense to you guys? Are you kind of following? Because what could it look like? Well, it could look something like this. Say I've got a triangle here. This is my first side. And then I'm going to draw a red side as if it's directly on top of it. Or let me start differently. Here's my red side. I'll draw it like this. And then I could have a blue side that would attach it, right? But let's say I swing that red side down all the way here. So I'll make the red side exactly the same length, but now I put it right on top of the black line. Does that make sense to you guys? Well, if the red side and I have another blue side, if the sum of the red and blue is not as big as the black, right, then there's no way for them to connect. Does that make sense? if the sum of the red and the blue is equal to the black, then they can connect, but it's not a triangle yet. Does that make sense? So the only way for them to be a triangle is if the sum of the red and the blue is more than the black. Does that make sense to you guys? And that's what the triangle inequality says. The triangle inequality theorem says that the sum of any two sides of a triangle has to be greater than the third side. Is that clear? Okay. So, what would that look like in terms of a problem? Well, it would look something like this. So here's the triangle inequality theorem. It says the sum of any two sides the sum of any two side lengths of a triangle is greater than the third side length. What would it look like? Well, it would look something like this. Go to page 755. Okay. And 755 and take a look at these examples. Guys, if you're on computers, I'm trusting that you're like following along in the book and not doing something for another class or something. Okay. Now, and why don't everyone just close your computers? How about that? And if you need to use your computer in my class for some reason, you got to talk to me because we don't usually use our computers in this class. Now, let's take a look. 4 plus 8 is greater than 10. Okay, so let me slow down. I'm given three side lengths of a triangle, 4, 8, and 10. The question is, can this make a triangle? It is your job to figure that out. Well, how do I check this? Well, I add up all the two side lengths and see if they're greater than the third. So for instance, 4 plus 8 is 12, which is greater than 10. So that gets a check mark. Then I add up another two sides. 4 plus 10 is 14, which is greater than 8. That gets another check mark. Then the third set of sides, 8 plus 10 is 18, which is greater than 4. So all the pairs of sides are greater than the third side. So it can be a triangle. Does that make sense? Check. Now let's take a look at this one. I have 7, 9, and 18. So let's add up the angle pairs. 7 plus 9, well, that's 16. Is that greater than 18? No, negatory. Okay. Do I even have to check any more sides? Do I have to check any more? Sure. Technically, no. I already know that this cannot be a triangle. But what I will ask you to do on your test is check all sets anyway. Okay. Then this next one will be 7 plus 18, which is 25. Is 25 greater than 9? Yes. Then the last one is 9 plus 18. 9 plus 18 is greater than 27. 20. Wait, what? Sorry, greater than 7. 9 plus 18 is 27, which is greater than 7. And so it gets another check mark. But since I have one x, no. Bad, bad, bad. One rotten apple can spoil the whole bunch, right? Isn't that how it goes? Yeah. Whole peck. What's a basket of baskets?
Bushel.
Oh, bushel.
A bushel. One bad apple can spoil the bushel. All right. So there you go. This is soul lessons in math. All right.
Oh, yeah.
A bushel.
Yeah, it's a basket.
Okay. Okay. So, guys, don't pick bad apples. All right. Who can make an observation about this that would make our lives easier? Someone give me some insight into this. I'm adding all three pairs. Do I always have to add all three pairs?
No.
Why?
Because once you find out, it works.
Yes. But is there a way that I could check just one angle pair against one, or one pair of sides against one other side?
I'm assuming there is.
Yes. If I look, the biggest is already the biggest. I don't have to add it to anything else. It's already going to be bigger than the rest, right?
Yup.
Right.
So all I have to do is check the two smaller ones. 7 plus 9 is 16. That's not bigger than 18. Done. You see? Now, I'm going to ask you on test to show me all three. But do you see why, like, that's never going to be the case? Like, if you have a bigger side, it's never going to be smaller than a smaller side. It's just not possible. You see? So just a little bit of insight. But in terms of this theorem and how we're doing it, we're going to check all three. Any questions about that? All right, cool. Now, it's good to have those mathematical insights, though, I think. So go ahead and check number 6 and number 7. Determine if a triangle can be formed with the given side lengths. Explain the reason, please. And thank you. Did you say no?
Yes. We don't have
Oh, I thought you said no, as in I will not.
Oh, that as well. JK.
He said, please do this. No.
You see that?
It's like, wow.
Math doesn't work now. It doesn't work.
Math doesn't work
The
out.
side doesn't work. So what apple?
There you go. One bad apple.
One bad apple.
Oh man. Yeah, we did.
One bad apple.
I'm gonna make a rap about it.
There you go.
I have no idea.
One bad apple. Apples. That's bad.
Can you do that? Yeah. And as long as they're all bigger than. Well, then if they're, then the one that
For the record, guys, if you can, on a test, explain to me in detail why you only have to check one pair of sides versus the other, then I'll accept that too.
Okay.
you.
But you have to write out the sentence, and you have to make sure you explain it in perfect
You
detail.
would just say that it doesn't, you just say we have to be very complete.
I'm good with that. So we just want to do it once, we can write a sentence with it.
Yeah, but that sentence has to be fully accurate and complete.
So accurate meaning
It
add
meaning
the
that,
two smallest and make sure that it is greater than the largest.
but you have to tell me why that's okay.
Well, what would you say?
I would-
Why is that okay?
Why is that okay? It's okay because the largest side will never be smaller
So that would
than
be the answer again?
the smaller sides.
Okay, wait, let me write this.
No, I won't accept it.
I don't think.
All right, 12 plus 4 is greater than 17.
No.
12 plus 17 is greater than 4. 4 plus 17 is greater than 12. Shh, 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 shh.
Is that funny to you?
Is 16 greater than 17?
Oh,
No.
No, it's not
29 greater than 4? No. 21? Yes, it is. Greater than 12? Yeah. So this is not going to work. Okay. Check the two. Just be brave. Check the two smaller
If they're
sides.
equal,
If they're equal, then
does it work or no?
if they're equal, then it doesn't technically work.
Wait,
No.
I thought they had to be equal.
32. No, it has to be bigger.
So that one works. That one works.
This one works. Yeah.
All those sides work.
Works.
Does that make sense? All right. Any questions?
So I think it-
Good.
Oh wait, no, I just did the same one. Wait,
I was following
I
along.
did the same
Shh, no, you should be doing the work on yourself
one.
independently. All right. Yes, sir. Go ahead. Shh, 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 shh. Let's continue. Now, what's the second part of this lesson? We know if given 3 side lengths, whether or not it can be a triangle, but the question is, if I'm given 2 side lengths, the new question, if I'm given 2 side lengths, what are the range of possible values for the third side? So let's bring back our diagram. Let's bring back our handy animation. Let's take a look. So the blue side is fixed, the red side is fixed, the green side gets longer or shorter. What's the shortest? Okay, wait. If I'm asking you the range of possible side lengths, what are some words that come to mind if I say range?
Possible, multiple possible.
Possible
X.
values, x.
Oh no, sorry, Y.
Y, but yeah, that was the case for functions, and that's good, I like it. But if I'm saying range, does it sound like I'm just going to say one value? No, it would be like a
range of values.
a range
Range of different
values. Okay, so a minimum and a maximum. A minimum and a maximum, right? So let's find the minimum. Let's find the minimum and maximum values of the green side. So what's the minimum value of the green side? 4. How do I get 4 from my other two values? Yeah, what do I notice about that 4? 4 is equal to 10 minus 6. You see that? Pay attention. 4 is equal to 10 minus 6. Now, let's look at the maximum value. What's the maximum value of the green side? 16. How do I get 16? 10 plus 6. Can the green side actually be equal to 16? No. Can it be equal to 4? No. So the range would be described as, how would you describe it? What's the range of the side values? 4 to 6. There's one word.
Come on, Jenny. You got it. Oh, it's
Exclusive.
Exclusive.
It's 4 to 6 exclusive because it doesn't include 16 and 4. So look, take a look at this. So it's got to be, the green side has to be not greater than or equal to 4, but greater than 4. And it has to be less than 16. Does that make sense?
Yeah.
No? Okay. So what is that? What am I saying? Say I've got a triangle. I've got a triangle and it's got sides 6 and 10. I ask you for the range of lengths of the possible value of x, which is the third side. Well, it's between 4 and 16. You see?
Wait, wouldn't the 1 be that way though? Because you can't.
No, x is greater than 4 and x is less than 16. So this is how I write in between. Yes, sir?
Why did you write 5? Why does it start at 4?
Because it's not just starting at 5. If I take a look at it, for instance, like it's not 5. The closest side could be like 4.05 or something.
Oh, okay.
You see?
Yeah.
So it's just greater than 4, but not necessarily like greater than or equal to 5. Okay, because I'm not just using integer values. Any questions on this? You guys get that?
I actually have a question.
Yes.
So when you say like 4, but like you end at 16,
Mm-hmm.
why wouldn't you know what?
So take a look at it. Watch it again. No. Just watch. Shh. Just watch again. Watch again. It goes from 4, then the green keeps getting bigger and bigger and bigger and bigger and bigger and bigger until 16.
Okay, so are we gonna have to be on this app like every time?
No. That's a very good question. How do I do this without that animation? Well, very simple. How do I get the lower value? I subtract the 2. How do I get the higher value? I add them. So for instance,
That's smart.
no.
Oh.
That is so smart.
So for instance, let's say I've got one that's 5 and 9. Let's say I've got one that's 5 and 9. How do I find it? Well, I do 9 minus 5
And then 5 plus 9.
and 9 plus 5, exactly. And I get x is greater than 4
Oh,
and x is less. Why is there so much chattering in this classroom? Shh. You see? Shh. Now, would I ever do 5 minus 9 and get like negative 4?
never.
Why not?
Because that's awesome.
Why is it impossible?
Because you can have a negative triangle.
Yes, you can't have a negative side length. You can't. Good job. All right. Shh. Now, let's take a look. Go ahead, number 9 and 10. 757, number 9 and 10. Go ahead. Do them. Find the range of values. Go. Quick, everyone.
Wait, 6 and 10?
Number 9 and 10. 757 in your book. 757, number 9 and 10. Go ahead. Go. Quickly. Come on.
You're so loud in this class.
I know. And you know, she's seen 3 of my classes now. You've seen a different dynamic in 3 different classes? Yeah, I guess so. You hear that, guys? I'm loud in the class. See what you bring out of me.
Yahweh's a warrior. Yahweh's a warrior.
I think it's
What is it?
It's better than me being up there. Welcome.
Sorry, I'm getting too high.
Okay, yeah. We're getting too high. All right. All right. Okay, let's take a look. First off, now listen. Whenever I'm doing a math problem, remember that you have to remember the process. So what is the process here? Subtracting and adding. How can I create a memory trigger for myself so that it's easier for me to remember it? Well, whenever I see a range of values for x, for a side, I just draw this. You see? And that'll trigger me because it'll say, oh, how do I get this one and this one? Well, I subtract for this one and add for this one. So 21 minus 14, 21 plus 14. Here it becomes x is greater than 7, x is less than 25. Oh, 35. That's 14. Okay, this one, it's 18 minus 9 and 18 plus 9. X is greater than 9 and less than 27. Any questions on that? Okay, so that's the second thing that we went over today. The next thing is this. Ordering a triangle's angle measures given its side lengths. And we're actually going to skip a little bit.
What do you mean by ordering? Like,
Ordering a triangle's side lengths giving its angle measures. So let's take a look at this other handy-dandy diagram.
is Amanda not in this class anymore?
She sure is. She's just not been here.
Wow.
All right, let's take a look.
Right there.
Is she right there?
No, she.
Oh.
I thought you were talking about Paul, and I'm like.
Oh, no. No, Amanda's there. Yeah. You guys switch places. Okay, now, again, I've got a red, a green, and a blue side, but now pay attention. Guys, pay attention. I've got a red, a green, and a blue side. Okay? Okay. The blue side and the green side are fixed. The red side is not fixed, and the angle is not fixed. So this angle, this orange angle, if I make that bigger, what do you think will happen to the length of the red side? Bigger or smaller? It'll grow. Okay, so let's take a look. Hey, I increase the angle. The side, you see, there's the side length. It's 5.4. If I decrease the angle, look at that. You see? It's quite clear. Okay, if I increase the angle, the side length increases. If I decrease the angle, the side length decreases. I think that's pretty obvious, right? Okay, well, the same thing is true for angles inside of a triangle. Now look, the relationship between angles and their opposite sides. So let's draw this triangle here. Let's say, guys, that this side here is 12. This side here is 4. And this side here is 8. Okay? Girls. Thank you. Okay. This is vertex A, this is vertex B, this is vertex C. Which of these will have the smallest angle? A, B, or C? Raise your hand if you think A will have the smallest angle. Raise your hand if you think B will have the smallest angle. And C?
I think A.
A. It's opposite the smallest side. Okay, which one will have the middle angle? B. Good, because it's opposite the middle length. And the longest, the biggest angle? Does that make sense? Okay. All right. So if I were to write the angle measures from order from smallest to largest, it would be angle A would be the smallest, angle B, and then angle C.
Oh, that's what you mean by ordering?
Yes, ordering from smallest to largest. So let's take a look. Let's take a look right here. Example number 11 on the middle of page 758, 11 and 12. Go ahead and you do it. It says order its angle measures from least to greatest. Thank you.
Can I borrow this pencil just right here? Sure. Thank you. It's a long answer. Antoine?
It's so easy.
Praise God.
If you're using your brain, you know what you're doing.
Okay. Side BC is clearly the smallest, so that means angle A is the smallest. Then side AC, so angle B is the middle. And then side AB, so angle C is the largest. Here in this one, angle B is clearly the smallest. Then followed by AB is the middle side, so angle C is the middle. And then BC is the longest, so angle A is the biggest angle. Is that clear?
Yes, sir.
All right. The same thing is true in reverse. What does that mean? If I've got a bigger angle, then I've got a bigger side. So go ahead and do questions 13 and 14 on the middle of page 759. It's basically the same exact thing. Except instead of I'll do number 13 actually real quick, just in the interest of time. This is clearly the smallest angle, so this is the smallest side, BC. A side always has two letters. Okay. This is the middle angle, 15. So that's the middle side, AC. And this is the largest angle, 160. So that's the largest side, AB. So now you guys can go ahead and do number 14. No, because I'm about to do that.
Okay.
You can just run it over. Go. Okay. First off, angle C. What's the measure of angle C? 90 degrees. Very good. So this is the smallest side angle, so the smallest side is AC. This is the middle angle, so that's the middle side is BC. And this is the largest angle at 90 degrees, so the largest side is AB. Any questions on that? All right. So next logical question is, what's your homework? Your homework is page 760, numbers 5 through 22.
That range is something else.
Yep.
1 and 2.
When you add the two first sides, it has to be less than, so for this
The
case.
sum of the sides has to be greater than the third side. Okay, now, I'm not quite done with you guys yet, so you need to pay attention because I'm about to go over what the quiz is on.
No.
Okay, so what's the quiz on? Well, it's lesson 15.1. What's lesson 15.1? Well, if we look back here, 15.1 is interior and exterior angles. What were the two main parts of this? It was the n minus 2 times 180 is the sum of the interior angles. And then remember, the other thing was the exterior angle, the measure of the exterior was equal to the sum of the two what? You guys remember this? To what interior angles? Blank remote. You guys remember this? The exterior angle is equal to the sum of the two remote interior angles. Okay, that was 15.1. 15.2 was isosceles and equilateral triangles. And what's an example of that? Was like on an equilateral triangle, that's one we just went over. We'd have like 2x and then 4x minus 8 or something, and you'd set them equal to each other. 2x equals 4x minus 8, and you'd solve for x and plug it back in to get the side. And then the other thing was like the isosceles triangle, where you'd have something like this, and this was x, and this was like 3x or something like that. And then you'd add them all up and set them equal to 180, right? And then the last thing, so that's the two things from yesterday. Last thing is 15.3. And what did we do today? Well, the first thing that we did was the triangle inequality theorem, which says any two sides have to be greater than the third side. That was the first thing we did. The second thing we did was the range, and we subtract to get the smaller and add to get the larger. And the third thing we did was we showed that bigger angles mean bigger sides in a triangle and vice versa. So bigger sides mean bigger angles. That make sense? Any questions on that? This is your quiz that's going to be tomorrow. So make sure you guys, I'm sorry, not tomorrow. You don't have my class tomorrow. Whoa.